Hello everyone, and hope you're doing super great. So today we're going to see how we can create circular motion in the Godot engine. And let's just quickly begin. Before we start, I just want to hit you with a little bit of the theory behind circular motion so we understand why I'm actually using some of these concepts. So say we have an apple just sitting over here, right? And then we want this apple to move along a path. So I'll just think about an imaginary circular path, just like we saw this apple rotating in the example. Now, imagine if we had a rope tied from the center of this circle, and this is going to be rotating in this direction like so. And we're going to use basic trigonometry to solve a few problems. Now, what we're going to do is to create an axis. So let's say from here, we're going to have our horizontal x-axis. This is negative, this is positive x, like so. And then we're going to have a vertical y-axis like so. And basically, we're going to have a parallel line like this so that we can complete this to form a right angle triangle, and I'll call this angle alpha. Now this is going to be our x component here, and this is going to be our radius, basically, which is the distance between this origin O and our apple, and then this is going to be our y-axis, because remember, these are parallel lines. So to simplify this drawing, I'm going to have something that looks pretty much like this, and where this is our apple that's following this orbital path, and we have an angle alpha, or anything you want to name this, and we have our radius, or which is our hypotenuse or the longest side, and we have our x, and then we have our y right here. Now you might be wondering, why are we talking about this when we want to use a game engine? Well, we're using this because this x is going to be our position, our x position, x pause in our game engine, and then this y is going to be our y pause in our game engine. And trust me, every mathematical concept we use here is going to be applied in the game engine. So we're going to use a trigonometry rule with the sine and the cosine. So I'll just say sine and the cosine of the angle. We're going to use this to find a relationship between the angle, the radius, the y, and the x-axis. So basically, trigonometry is going to bind all these together so we can use that to solve the position and the location of the x and y. Now for sine, that's the opposite over the hypotenuse. So my sine alpha, which is the angle which I'm going to be rotating, and remember, our angle, which is this alpha, is going to be increasing as we reach this point, or actually any point. As long as it's rotating, this angle is going to be increasing. So let's say the sine is going to be our opposite, which is y, over our hypotenuse, which is r. So basically, if we divide this by 1 and actually multiply, our y is going to be equal to our radius multiplied by the sine of the angle alpha. And let's try to do the same thing with our x right here. So for our x, we'll use the cosine because that'll give us a relationship. Now the cosine is going to be, let's say cos is going to be equal to the adjacent, which is this baseline here, x over our hypotenuse, r. So our x will be equal to r, and there's an alpha here, r cos alpha. And basically, these are the two equations we're going to use to represent our x position. So if we switch this x here, and we switch this y here, we're actually going to use that in our game engine to see how we can rotate an object at a fixed origin from a specified radius. So we're using all this information right here using basic trigonometry to see how we can move this object in the game engine, which is exactly what we're going to do right now. So let me just minimize this, and I'm going to quit my project and quit to project list, and I'm going to create a new Godot project. So I'll just go to new project, and I'm going to call that rotate underscore objects, and I'm going to save that in a Godot folder I have in my documents. I'm going to create folder, and I'm still going to call it rotate underscore objects, and click OK. So in rotate objects, I'm going to create that folder. Whoops, sorry, I'm going to select the current folder first. And I already have a rotate objects in the Godot project folder. So I'll just click create and edit, and this should actually build our project. So the first thing we need to do is to find a piece of art, a sprite, or an object we want to use. In case you don't have any of that, you can use the default Godot icon SVG, and let's just use that per se. So the first thing I'll do is to create a 2D scene. And once I've created that node, I'm just going to call this my main scene, because I'll keep this super simple, and then we'll save that scene in a scenes folder. So I just clicked create a new folder and create folder, and I created a folder and I gave it the name scenes. And within scenes, I'm going to save my main.tscn file. Now, because this is such a simple project, I'm still going to attach a script and save the script within the scenes folder. So to do that, I'll click on attach script, and here where it says scenes.main, I'll just create the script because I just want to make this as simple as possible. Nothing super complicated here. So now that we've done this, let's go ahead and increase. So I'll just use Control and plus, just increase our script right here. So we have a main scene and we have a node. So what I want to do is to attach or drag in my piece of art right here. And here I'll just click on this section here, and I'll search for a texture rect, and I'll hit the return key. So now that I have that texture rect, on the texture property where it says empty, I'm going to drag my icon.svg and just drop it here. I won't see this because I'm in my scripts view. So I'll click on the 2D view, and then voila, we have the unfortunate Godot icon, which we're going to be spinning around real soon. So basically what we're doing is that this is going to be a child object of our main scene, and it's going to be inheriting from any of these scene properties. So any script that I have in this main.gd class, anything I tell it to do, it will actually affect the child object as well. So the first thing we'll do is to declare our variables. So I'll just say declaring. I'm having a little bit of problem spelling today. Declaring our variables. So now I've had this to create our variables. What we need to do is to set a radius for our circular path. As you can see right here, we said we needed a radius. So let's create that variable. So I'm just going to say var radius, and I'm going to set the data type to float using type hinting in Godot. And I'll set that to a value of, say, 120. So that's going to be our radius. So next, I'm going to create an angle. So let's create our angle. I'm just going to say var angle, and I'll reset the data type to float, and I'll set this to 0.0. And basically, it means this object is going to start from an angle of 0, and then we'll be incrementing that angle. And how fast do I want this to move? So let's set a speed. So I'll just say var speed colon float data type, and I'll set this to say 1.5, like so. So the next thing I'm going to do is to create in the update method, which is going to run every frame. I'm going to be increasing the angle as well as the value of our math expression. And to do that, let's create our process function that will run every frame. So I'm just going to say underscore process, and then we'll pass in delta and I'll say pass. And by default, you might actually have a start and a process method right here in your project. Don't forget to use func to specify that this is a function, or else we'll get an error. So basically what I want to do now is to increase my angle based on how fast we're moving per frame. And to do that, I'm just going to say my angle. It's going to be plus equals, which is the same as saying angle equals angle plus. I'm just going to say my speed multiplied by, let's use our delta to multiply this value. And I'm just going to say delta. And one of the cool ways of using Godot is to create our own custom function, which we'll just call in the process function. I think that's better. So I'm going to say func circular underscore motion, like so, and I'll pick my data from here and I'll place it in my circular motion function. And here in my process, I'm just going to call our circular underscore motion function, which we've created right now. I believe that's actually a cool way of doing this. And instead of using delta, I can actually use the get process delta time. It's still using delta, but we don't have to pass it as an argument. Basically, if I do it like this, it means within this circular motion, if I want to call it, I have to pass in delta here and delta here. But if I just do it like this, I don't need to pass in delta into this as an argument. So that's going to settle how we're going to be increasing our angle. So the next thing we want to do is to calculate our new position using our polar coordinates. And remember, we said we're going to use our x position and our y position using the sine and cosines and increasing those sine and cosine angles. So to do that, let's create a variable. So I'm just going to say var x, and this is a local variable because we're creating it in our function. So it's not going to be accessible anywhere outside the scope, but only callable in this function. So our x pos is going to be equal to the cosine of the angle, and then our var y underscore pos, which is our y position, is going to be the sine of our angle, like so. So now that I have these two values, what I'm going to do is to set my x position and also set my y position to use this radius value. Here we're just specifying and holding a reference to the cosine and sine of the angle. So now I'm going to set my game objects x and y positions. Basically what I mean is if I go back here and I click on this move gizmo, you can see we have a red handlebar and a green handlebar. And if I click on this and go to the inspector, I'll just click on this and go to the inspector. On the transform, I'm going to set this x and y value. So basically that's what I'm going to set in the script right now. So I'm going to get my position dot x, and this is going to be equal to my radius. I'm going to multiply that by my x position, x underscore pos, and for my position dot y, I'm going to multiply that. I'm going to set the radius multiplied by, you guessed it, the y underscore position. And then in our process function, we've actually set this to our circular motion. So let's save this and let's press play and see what happens right now. So I'm going to select the scene and set it at the current scene. And we should actually see our object rotating smoothly, but there's a little problem. It's actually rotating at this top left corner, and we want it to be somewhere at the center here. And to do that, it's just a simple fix. We're going to add an x and a y offset. So let's try a value for our x offset. Let's try 150. And we'll add our y offset as well to be 150. Basically, it's saying don't start at the 0, 0 origin here, but shift this object 150 here and 150 here, so we can have this at the center when it starts. So let's go ahead and play the scene and see the difference. So now we can actually see it's a bit away from the origin point, and you can set it to any value you actually want. Now, to make this much more readable, what I'm going to do is, instead of hard coding values like this, I'll just create these two values right here to represent our offset. So I'm just going to say var x underscore offset is going to be equal to 150, and technically we can just use one value for the offset, so I'm just going to call that underscore offset instead of creating another one for the y, since I'm going to be using the same thing. So I'm just going to say underscore offset and plus underscore offset, like so, just so we can have something we've coded like so. So if I play this, we'll have the same kind of results. And if we wanted to set this separately, in case you want to experiment and set separately, let's do underscore, let's call this x offset, and let's call this y offset equals to 150. So we can do our underscore x offset, and we can do an underscore y offset here, so you can have this object and change these values if you want. And we can even do an at, oops, we can say I'm trying to use at already. Good. So I wanted to do this and say at like so. I believe it's on ready. And if we do this, what this will do is to make this, and let's set this one to at. So if we do this and save it and go back to our inspector on our main scene. Okay, I actually forgot, but there is an option to expose this parameter. Let's see if we can get at export. Sorry about that, guys. It's at export. We're using this to actually specify the variable when the scene is ready. So I'm just going to say at export and at export. And basically what export does is to expose this X and Y offset parameter on the main scene when we're actually here. So we can see our X offset and Y offset as 150 and 150. Let's just go ahead and play this. And what we can do is to change this to say 200. And then kind of like observe this. I think I can try to observe it. And basically that's what the add export does. You can just change it directly right here rather than always going into the script. And you can see those changes you've made. So yeah, thank you very much for watching, guys. And let's see what happens if we change our speed, let's say to 2. And let's just experiment and test this. So we can see we're moving a bit faster, and see what happens if we set our radius to 60 and play that scene as well. So now we have a shorter radius where this object is orbiting, and it seems to be working. So basically that's how you can create circular motion and have fun in Godot. And what you can also do is to look at any mathematical equation. Let's say an equation like y equals to, say, x. I think it's power, x, let's say position dot x comma 2. You can actually use this to plot this graph and this function and see how it's going to affect the x and y position. And this could actually be, say, position dot y, and you can actually set that. So y is a function of x, and you can set the power of x raise the power 2 and see what happens when you create a function like this and plot it with Godot. So thank you very much for watching, guys, and I'll see you in the next Godot tutorial. Let's Godot. Peace.